Alright, in today's video we're going to be moving on from linear functions. We're now going to be starting to look at what we call an exponential function. An exponential function is, another way to look at it is possibly like repeated addition. Okay? Now, just like our linear functions, to define if it's an exponential function, we're going to sort of look at things that are happening to our x and our y values. Okay? The first thing we want to look at is our change in x. Okay, we want to see if it's constant. Alright, well first of all, our change in x each time here, you can probably very easily see our change in x is simply just a value of 1. Alright, so we have a constant of 1. Now we want to look at the ratio of our y. We're no longer looking at the change, we're looking at the ratio. Now what do I mean by ratio? Well, we're going to take these two values and we're going to divide the second one by the first one. Okay? So 5 over 1 is simply just 5. 25 over 5 is also 5. 125 over 25 is 5. And 625 over 125 is also 5. So we have a constant ratio of 5. So since we have that constant ratio each time, we can say yes, it is exponential. Alright, so let's look at our example 2 now. Alright, well in example 2 we're going to look at our change in x. Alright, and it is a 1 again every time. Alright, but let's look at our ratio of our y values. Alright, so we'll do 4 over 8, gives us 0.5. 2 over 4 is also 0.5. And if you need to use a calculator to find these, go ahead and do that. That is not a problem. 0.8 over 2 is 0.4. And 0.4 over 0.8 is also 0.5. Well, if you notice, this value right here is not the same as the rest. Okay? So our ratio of y is not the same each time. Alright? So we would therefore say, no, it is not exponential. Alright? Well, let's take this even one step further and let's actually determine if we can get the exponential function from this. An exponential function, just to sort of refresh your memory if you have not seen these or if you don't remember these, an exponential function looks like y equals a value, we'll call it a, times a value b raised to the x power. Okay? So, first thing we need to look at is we need to look at our change in x each time. And our change in x is 1 each time, so we're good there. Now let's look at our ratios of our y values. Alright, so we're going to do 10 over 4, 25 over 10, 62.5 over 25, and 156.25 over 62.5. Alright, well if we do the division on all of these, again use a calculator if you have one handy, we get that the ratio each time is 2.5. So they are all the same. So We can therefore use an exponential function on this. All right. Now, in order to write our exponential function, first of all, our b value is equal to whatever the ratio was there. All right. So in this case, our b value would be 2.5. Well, now to get our a value, since we don't have a 0 here, we need to find a 0. So we need to basically go one step back and get where x equals 0. All right? Well, if we go one step back, you'll notice we're multiplying by 2.5 each time. 4 times 2.5 gives us 10. 10 times 2.5 gives us 25. So instead of multiplying, we're going to divide. So we're going to take that value of 4 and divide by 2.5. All right? When we do that, we get a value of 1.6, and that becomes our a value. So our final function is y equals 1.6 times 2.5 raised to the x power. All right, let's try this one more time on example 4. All right, example 4, you'll see our change in x each time is again a value of 1. All right, so now we're going to look at our ratios of our y values. Our ratio on our first one is 400 over 1,000. Second one is 160 over 400. Next one is 64 over 160. And our last one is 25.6 over 64. If we punch these in the calculator and get a decimal for these so we can compare them, you will notice that the value we get for each of these is 0.4. Okay? So therefore we know our b value is going to be 0.4. Now remember, to get our a value, if we do not have 0, we need to take a step back to 0, okay, to get the value here. We're going to take the y value for 1, which is 1,000, and we're going to divide it by our b value. In this case, if we punch that in our calculator, we get 2,500 as our a value. And now we can write our function, y equals 2,500 times 0.4 raised to the x power.